All right, so Fundamental Theorem of Calculus Part 2 is based on the fact that if derivatives and integrals are inverses of each other, then that means that the integral is the antiderivative of the function, which is what you sort of picked up on when we were doing that activity on Thursday or whatever it was, okay? So the Fundamental Theorem of Calculus Part 2, this is what it's all about. This is how we're going to solve all these problems. If you need to evaluate the integral from a to b of a particular function, the way you do it is by evaluating the antiderivative at b minus the antiderivative at a. I mean, yeah, kind of. You're going to know it so well because we're going to use it so much that in one sense you don't have to. But it's, maybe worth it, okay? So the way we're going to solve integrals now, instead of like drawing the area or plugging in the points or whatever, is we're going to find the antiderivative of the function. And then we're going to take the top number and plug that into the antiderivative. And then we're going to take the bottom number and plug that into the antiderivative. And we're going to subtract those two answers. Okay? So it turns out to be really simple to evaluate integrals. And you're welcome for, I think we only spent like 2 days doing it the long way. Not nearly as bad as when we were doing derivatives. Okay? All right, so let's evaluate the integral from -2 to 1 of x cubed dx. Please don't ever forget what we're actually doing when we're doing integrals. What we're doing is we're finding the area underneath the curve. I'm sorry, I shouldn't say underneath the curve. We're finding the area between the curve and the x-axis from -2 to 1 of x cubed. All right? So we're taking this function right here, the old x cubed function, and we're finding the area from -2 to 1. What is one thing that you know about the answer looking at that graph? It's going to be negative. Why? Because there's more area underneath than there is above. Yeah, okay? So we should expect a negative answer. All right, so we're going to go -2 to 1, x cubed dx. What's the antiderivative of x cubed? That's the derivative. The antiderivative of x cubed. It is x to the 4th over 4. Okay? Remember, when you take a derivative, you subtract 1 from the exponent and multiply. When you do an antiderivative, you add 1 to the exponent and divide. Okay, now we're not doing a plus c thing here because this is a particular thing that we're trying to find. The notation that you do now is you put a little square bracket there and a 1 and a 2. And then we're going to plug in the top number. Oh, yeah, thank you. We're going to plug in the top number first. What do I get when I plug in 1 to x to the 4th over 4? 1/4 minus, then I'm going to plug in the bottom number. -2 to the 4th is 16, but then 16 divided by 4 is 4. So the answer is -3 and 3/4. Okay? Yeah, very cool. That's the answer. That's the exact answer to the area in between the curve. It's just a notation to say, now that I've taken the antiderivative, I still have some math to do with it. I had to plug in the 1, and that gave me 1/4, and then I plugged in the -2, and that gave me 4, and then I subtracted those two things. That's it, yeah. Almost, yeah. Yeah, it's only an 8-slide day. What? That's what I'm telling you. Yeah, Fundamental Theorem of Calculus Part 2. Yes. Amazing, isn't it? We only just spent 2 days, so don't worry about it. Yep, you always do the top number first. Okay, you go from top to bottom. Payson? Okay, we'll get to that where we are finding, we'll get to that. Okay, yes. How could you, oh, this you can't. This is asking, yeah, this is asking different questions. So this will not help you on that quiz, sadly. Hold up. Okay. All right, so let's play again. So this is just stated in words what the integral is actually doing. Find the area under the parabola y equals x squared from 0 to 1. We already know the answer to this. I don't know if you remember, but we did this using adding up an infinite number of rectangles, taking the limit as n approaches infinity, all that kind of stuff. So that means we're going from 0 to 1 of x squared dx. That's how you... Okay, x cubed over 3. The area is 1/3. Yeah. Yeah, easy peasy, right? Oh yeah, for sure. We're going to spend the whole rest of the semester working on there you go. Yep. All right. So find the area under the parabola. That means take the integral. Just like find the derivative means find the slope. Okay. From 0 to 1, antiderivative, add 1 and divide instead of subtracting 1 and multiplying. Plug in the top number, plug in the bottom number, subtract the two answers, move on. Okay. Hey, what do you know? Find the area underneath the cosine curve from 0 to b. Well, let's figure that out, shall we? Yes, sir. No, that's incorrect. Sine x. That's it. The derivative of sine is cosine. Therefore, the antiderivative of cosine is sine. And then you plug in b. And then you plug in 0. The sine of b, we don't know. The sine of 0 is just 0. So the answer is b. Yep. So if you're going from 0 to a number, as long as it's in between 0 and pi over 2, if you get past pi over 2, then you get some negatives in there and things get a little bit more complicated. But to find the area underneath the cosine curve, in that first little piece right here, all you do is you take the sine of whatever that value is, whatever that number is, and that, yeah, well done. And that gives you the area of the region. Okay? Super easy. Okay, what's wrong with the following calculation? This person was asked to do the integral 1 to 3 of 1 over x squared dx. They changed it into, they took and said 1 over x squared is the same as, x to the negative 2, right? And then to do the antiderivative, you add 1 to the exponent and then divide. So they added 1 to the exponent and got x to the negative 1, and then divided by negative 1. Did that from negative 1 to 3. If you plug in 3, then you get negative 1/3. If you plug in negative 1, you get 1. Subtract those and you get negative 4/3. What's wrong with this picture? They did something wrong, yeah. They did something wrong that you're never going to get it. Maybe. Uh-huh. It's not an algebra error, it's a calculus error. I'm going to get it. It's 1 over x cubed. No, that's the correct answer. Yeah. If I take the derivative of negative 1, if I take the derivative of that, I would put the negative 1 in front and subtract 1 from the exponent. The negative ones would cancel and I'd get x to the negative 2. No, you're never gonna get it. The answer is that there is a infinite discontinuity in between those two numbers, and so you can't take the integral then, because that's what I'm here for, Tegan. Okay, here you go. This is an inspirational thing. I should make you guys all stand up and salute the flag while we say this together. The fundamental theorem of calculus is unquestionably the most important theorem in calculus, and indeed, it ranks as one of the great accomplishments of the human mind. Before it was discovered, from the time of Eudoxus and Archimedes to the time of Galileo and Fermat, problems of finding areas, volumes, and lengths of curves were so difficult that only a genius could meet the challenge. But now, armed with the systematic method that Newton and Leibniz fashioned out of the fundamental theorem, we will see in the chapters to come that these challenging problems are accessible to all of us. God bless up. Oh, sorry. It's just like inspirational. You want me to read that again? The secret word is what? I don't know. I don't know what you're talking about. Even though they signed that guy? Oh, you mean this year? That's because the Pac-12 has not done themselves any favors